Hey A-level physicists, what's the crack? So what we're going to do today is we're going to look how does the magnetic force and the electric force work inside cyclotrons, okay? So just talk for us what a cyclotron is. So a cyclotron is made of your two Ds, and between your two Ds there's only going to be an electric field, right? Because it's connected to an alternating supply. So an alternating supply just means one time this is positive, and then over another cycle it becomes positive, negative, positive, negative, positive, negative. Okay, so we're constantly switching the electric field directions if it's going to the right or going to the left. Then inside the two Ds, we've got a magnetic field. It says magnetic field is going to be acting into the page. Okay, so it wants us to explain how come a proton, there's my proton source, how come if a proton gets emitted, it will travel in this direction? How come it travels in a circular path? Okay, and the equation from your data sheet you want to think about is F equals BQV, right? So what we have is we have a proton that's moving with a certain velocity, and the velocity of that proton is perpendicular to the magnetic field. So if I look at my velocity, it's traveling in this direction towards my right, but the magnetic field is going into the page. So because the velocity and the magnetic field are at perpendicular direction to each other, there's going to have a force that's also in the perpendicular direction. Okay? So because the magnetic field is perpendicular to its velocity, that's why we get a force in that perpendicular direction. And again, you can remember this from Fleming's left-hand rule. From Fleming's left-hand rule, or F equals BIL, or FBI, thumb is the force, your first finger is B, and your second finger is the current. So I remember current is the direction of my conventional current. So remember, conventional current is the direction that a positive charge moves. So my proton is positive. So my conventional current right here is going in that direction. My magnetic field, we said it was going into the page or into my board. So I can clearly see the force right here is pushing it up. Then if I look at this point now, again, I can see what I've changed is the velocity now is moving up the board, and magnetic field is going into the board. And now there's a force pulling it in this direction. So we can see there's constantly moving a circular path because the magnetic field is perpendicular to its velocity, and because the velocity is then going to give me a perpendicular force. Okay, so your mark scheme, you just want to make sure you mentioned that travels in a certain circular path inside the Ds because the magnetic field is perpendicular to the direction of velocity, and that gives me a force in the perpendicular direction. And that force we're going to mention then is our centripetal force. That's your second mark there. For mention that's a centripetal force because it's pushing it towards the center of the circle. Okay, so that's your 2 marks. So that's grand.